an overview of statistics. Hey, what is statistics? So we're going to define what that is. We're going to talk about the difference between a population and a sample, parameter statistics. We'll talk about descriptive statistics and inferential statistics. All right. So let's talk about data. What is data? Where does it come from? It's just information we get from observing stuff, counting, measuring, taking responses. Data is everywhere. And really, just this definition is what you need. These examples, if you don't want to take the extra time to write it back down, that's okay. So a lot of times we get some data, and we use that to influence our decisions that we make in the future. And that's really what statistics is. All right, so statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions, just like I said. All right, so this is fairly important terminology. I'll be using this a lot, right? We take samples from a population, right? And the idea is we want to know some information about a particular population, right? We'd like to know something about all of the students here at Cleveland High School, right? But it might take a lot of time and resources for us to ask every single student a question or to get a certain particular piece of data from every single student, right? Maybe we'd like to know if you are a better test taker when you're chewing gum, right? If we went through an experiment that involved every student, it would take a lot more resources, right? It would take more time. We would have to buy gum for all these students, right? Instead, it would be better for us to take a representative sample of those students and then see if we could maybe generalize that data to the whole population, right? So if we were going to take that type of a sample, I'd have to be careful and not to just walk into, let's say, a U.S. history class, right? And get data, because I wouldn't be getting all the students, right? U.S. history is specific to a grade level. So I'd probably only get those students in there, right? I wouldn't want to walk into Algebra 1, because all I get is freshmen. So I'd have to somehow sample a group of students that represented the entire population, right? We'd have some freshmen, some sophomores, some juniors, some seniors in there. We'd probably also want to make sure that they all come from different socioeconomic backgrounds, right? We want to make sure that that there was an even distribution, maybe advantages and disadvantages that people have and stuff like that. There's all these different elements that we could look at, right, to make sure that we get a sample that represents our entire population. We don't want to skew that by maybe like getting only boys or only girls or something like that. There's just so many different ways that you could look at the differences in the population just to make sure that you get a well-rounded sample. We'll discuss that at length when we get into experimental design. All right, so let's identify a data set. I won't read this to you. You can read it. All right, so in this case, we're being asked to identify the population and the sample. So 1,500 adults in the United States were asked if they thought there was a solid evidence for global warming. All right, so this is where it's at right here. We're looking at adults in the United States, right? That's our population. we're taking a sample of just adults. They haven't clarified what kind of adults, just adults, right? So our population is adults in the United States. And let's see, the data set is these 1,500 adults. We can describe it, and the way that we would describe it was we would talk about the 855 that said yes. And then you can figure out how many said no by subtracting. Yeah.
Would the population be 1,500 and the second would be 855?
So the sample, so the population is referring to the
Number of the sample.
Total.
total, everything. So if I want to know something about all the adults in the United States, that's my population, right? But in order to find information about all of the adults in the United States, I'm taking just a small piece of that so that I can kind of generalize.
So then the sample of the population.
So the 1,500 is the sample.
There's more than 1,500 adults, right? Think of the population of Cleveland High School. Everybody here right now, currently, that's the population of Cleveland High School. This class is a sample of Cleveland High School, of the population. Does that make sense?
All right. And then the answers here as well. So we talked about their answer as well. So, all right, 1,500. Just what we were saying. All right, so try it on your own. Let's identify the population and the sample. Okay? So yeah, we have to keep in mind we're looking at prices, right? But I like that you're looking at that population is the whole that you're grabbing a sample from, right? All right, we're gonna move along. Okay, here we go. All right, so we're going to talk about the difference between a parameter and a statistic, and these two definitions are very important. A parameter is a number that describes the population characteristic. So, for instance, when the government takes the census, we're getting parameters, because they're really assuming that they've gotten data about all of the people, right? So I could get, if my population was just the people in this room, right? Just second period everyday statistics. If I was to collect all of your heights, right, and get an average, the average height of all the people in the room, that would actually be a parameter. Because I'm just talking about people in this room. Now, if I considered you guys a sample, maybe of the senior class at Cleveland High School, that is going to be a statistic, right? If I said, okay, I took a sample of a group of seniors, I measured their height, I found the mean height, and based on that sample said, I think that the mean height of seniors at Cleveland High School is that mean that I got. That's a statistic. You know what I'm saying? So statistic is data that I get from a sample, and a parameter is data that I get from that entire population of people, right? So if I was to then measure the height of every single senior here at Cleveland High School and then get an average, that average would actually be a parameter. All right, let's distinguish between the two. We got a numeric value. Let's see, is it a population parameter or a sample statistic? So we've got a survey of a sample of college career centers, and they reported that the average starting salary for petroleum engineering majors is 83 grand, something like that. All right, is it a parameter or a statistic? Oh, what's up? You're gonna answer? Okay, good. Huh? That's a statistic. What are we gonna say? Anything? Right, yeah, because it says a sample, right? So that's the key. That's the word there that points us to the fact that it's a statistic. They didn't say that they did the survey of all college career centers, but just a sample. All right, how about this one? The 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1,442. That is a parameter. Yeah. All right, 2009 Major League Baseball team spent a total of, wow, $2,655,395,194 on player salaries. Is it a population parameter or a sample statistic? What do you think?
So parameter.
Yeah, it looks like it's all of them, right? Not a sample, but all baseball teams, right? Looks good. All right. All right, so we've got two branches. We've got descriptive statistics. We've got inferential statistics. And we can use the water example that we did yesterday to kind of get this. When we first did the problem, right? When we first did the thing, you guys tasted the water, and we got a number, right? I forget what it was for you guys, but it was a decent percentage of you guys, right? So we figured out how many people got the, how many people were able to taste the difference between the bottled water and the tap water, and we wrote that as a proportion, right? And we said, hey, this percentage of you all were able to do it. At that point in time, we were doing just descriptive statistics, right? We said, hey, we've got this data. We were able to get a number from it. We didn't try to make any sort of conclusion about it, right? We just said, hey, this is the data. But then I asked you guys the question, was that percentage big enough to say that, you know, that you actually did know the difference, right? Because the only way to say 100% for sure that you all could taste the difference is that you all tasted the difference, right? Otherwise, we're going to be making an inference. We're going to be saying, well, there were enough of you guys that tasted it to say that, yeah, probably people in general can taste the difference. So that's the difference. With descriptive statistics, we're just going to be kind of saying, hey, here's the numbers. This is it. These are the numbers we gathered from data. Um, when we do inference, we're going to draw a conclusion about an entire population. Do you think that everyone in the class in general can taste the difference? Or do you think that people in general can taste the difference between bottled water and tap water? I'm not sure what this little picture on the bottom here is about. Okay, we're going to decide which part of the study represents the descriptive branch of statistics and what conclusions might be drawn from the study of using inferential statistics. So let's see. We've got a large sample of men. They don't say how many. They're all age 48. They were studied for 18 years. We've got, for unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. I think that just has to do with the fact that more unmarried men are base jumpers. Really. No, probably not. It might be true. I don't know. Would you marry a base jumper, ladies? I think it's a bad idea. Unless they have a good life insurance policy. I say that because it's one of the most dangerous. I think it is actually the most dangerous sport that you can participate in. More people die than, like, the proportion of people that die playing that sport or doing that sport is higher than any other sport. What's up, man?
I want to say history.
Oh, all right. What do you think?
Is it inferential stat? Because that might not necessarily be true. You said everything died ever.
Let's see. Well, so what we're talking about is, have we made any sort of conclusion based on the data, right? So, if there's, yeah, we're just describing what happened at this point, right? So, yeah, I was just checking to see if there was more stuff. So all we've said is, hey, I mean, I don't really see that there's been any conclusions made at all, really. But there's an answer. So we got the descriptive part, right? And just like I said, you could possibly make an inference that being married causes people to live longer. I went straight to base jumping, but I guess that makes more sense. All right. Yeah, possibly. I don't know, married men are healthier for some reason, or who knows? You have to look into that a lot more. But all those statements are inferential statements, right? Why is it the case that married men are staying alive, or there's a larger proportion of married men staying alive longer? We don't know. It could be because they're married. It could be because of base jumping, which I'm going to stick with. Alright. Let's see. We got a survey conducted among 1,017 men and women by Opinion Research Corporation International. They found 76% of women and 60% of men had physical examination within the previous year. So obviously, all we've been given here is some descriptive statistics, right? What type of inferences could we possibly make based on this data? Perhaps women care more about their health. Maybe women have more health issues than men. Will cause you to go get a physical more. Maybe they're more worried about it. Maybe they're more responsible. Yeah.
Are they saying that that number of men and women, 76% did that within them? No, they're making an inference about the population.
Not yet. All the things that I said before were making an inference. At this point in time, they just said, hey, we picked out this many, right, 1,017 men and women, and found that of those, we had a percentage, right? So it's just straight up, just numbers in front of you, right? Not making any kind of conclusion about it, but like, this is what the numbers say. Once you start trying to make a conclusion, then you're doing it.
Isn't it gonna be obvious, like they're gonna say it, and you know, can I see the first one?
You see one that has inference in it. Let's see if their description. Statistics can at times be a little bit disturbing. Okay, so we've gotten through 1.1. We have a classwork assignment